Okay, I'm live. Okay, so I had lunch, and I'm back. I'm gonna work on the closure, implementing closure in the play language. I actually didn't finish writing up the problems I'm gonna need to solve. So the first problem was displaying closure variables in the debugger. I thought about it, and I think I have a strategy. I think the strategy is to attach the closures into the frame objects, so that while the content of the closures will be outside of the frame, the references to the closures will be attached to the frame objects. That's the plan. And I think I'll be able to do that in this session here. Another problem I'm gonna have to solve is just the multi-level closures, which I mentioned, and then the third problem I think I want to solve, I think I need to solve, is the cleaning up of closures. Once you create this closure in the heap, you actually don't want that information to stay there indefinitely, because it takes up memory, and you need to know when to clean them up, when to get them out there. They should be cleaned up when they're no longer needed, but how do you know that? So that's another problem I'm gonna need to solve, I believe. I'm actually gonna put this in the to-do, perhaps, which I keep in my readme file. Actually, I'll call this closure problems to solve. Okay. That actually ended up being 3 problems, not 2. Alright, now let's continue. So the first thing I want to do is to attach the closure information onto the stack frame. Here, namely here, so that the debugger is able to display it. And then actually getting the debugger to display it, that's another story. So I think what I'm gonna do is extract the closure. I'll actually use var. I don't remember why I chose to use var here, but I'm gonna use var to match the immediate return value thingy. So when I'm pushing a frame, I'm also going to pass in a closure ID as well, in the event that we need it. There are events that don't need it, but this one is one that does. Actually, I think it may need to be an array of closures. So there's that. So now in the inner scope here, I'm going to do the same thing, because this frame needs access to this closure. And now if I update this push frame function, let me make this font smaller. Find the function update to take a closure IDs. Take the closure IDs and stick it into the, I'll actually call them closures to be less verbose. In certain situations, I prefer less verbosity. Okay, and this is 1 for some reason. Okay, so if you're gonna give me closures, I'm gonna stick it onto the same frame. So now let's run this code. And if we look through the stack frame, oh, history, so each element within the history is the state of the entire program, which it contains the stack. And this stack now, it knows about it, closure number 5. And where can I find closure number 5? It's in the heap, the thing with ID number 5, okay? So, I also could have just looked at this. Okay, so here, for example, we still have counter is 1, and yeah, the stack has access to closure number 5. And the debugger will be able to look at this, and basically when it's rendering the frame with all its variables, it can look at all the closures that we're needing again, grab the actual variables from the heap. Where's the heap again? There's the heap. Grab the variables from the heap, from that particular closure, and render it in this stack. In this stack display. So maybe we display it like closure number 5 or something, and it's got a counter variable. Its variable is I. So debugger has enough information to do that now after this addition here. So I feel good about this. And I think we might be ready to implement it. Maybe add a slightly more complicated example, possibly. Yeah, let's do a slightly more complicated example. The multi-level scope thing. Let's do the multi-level scope thing. This is another closer example. Let me think. I'm gonna make another one. Let's call it closure example 4. New file, closure example 4. And I think I'm going to maybe like take this chunk and say wrap it inside of a initialize function. We call it initialize UI. And after this function has been defined, I'll call initialize UI. I don't think I have hoisting working, so I'm gonna do it like this. I'm gonna get this is a dict is unneeded. Okay, let me compile this program. Compile closure example. Let me try to run the color coding on this. Oh wait, no, I want to closure example 4. That makes sense to me. And this is the case I wanted to test. It's a multi-level closure, so there are two. Ooh, a lot of wind. lot of wind hitting the side of my wall here. Okay, so we have two closures because we have three levels of scopes. This level, and this level. And the innermost function is dependent on a variable label in the middle scope. It's also dependent on a variable in the outermost scope, so it needs both of them. The middle layer doesn't need variables from the outer scope. That's worth mentioning. But let's go with this example for now. And I'm gonna, for now, I'm gonna manually modify the generated JavaScript to make the scheme work. I wrote a couple of functions in the previous example. I'm gonna steal them from that file. And that was, oh, I got rid of them. Can I undo? I can, yes. Whew. Okay, let me save these. Let me save this and put it in the runtime before I forget. Because if I forgot, they'll lose this code and that's no fun. I'm gonna move this get variable up so that I can see this get variable and set variable, get heap variable, set heap variable on the same place. Okay, so the runtime is going to do that. I'm gonna go ahead and recompile it so that this JavaScript, closure example 4, will already have get heap variable and set heap variable at the top defined. Okay, now what I want to do is say for this main, because I know due to static analysis, writing code, I'm going to have static analysis code that goes through the AST and figures out which function needs what closure variables, okay? And it's gonna find for me, I'll maybe call this like closure main, maybe heap allocate, and also I'm gonna put this in the closure array. Yeah, and due to the coloring, I can see that we need to save the counter. The counter is the only variable that needs to be in closure main. Should I go with closure main or closure 1? Let's go with closure closure $main, like that. Closure underscore main. Let's go with closure underscore main. Okay. So this one needs to have a closure, and counter is the one that is the closure. So this is closure, the variable that is in the closure. So when we set counter, that goes into this closure. And then these ones will be set heap variable closure main. It's kind of unfair that I'm using JavaScript closures to implement the closures in my programming language, but yeah. It is what it is. One more. Okay. So those are the references for counter, I believe. Yes. 1, 2, and 3. Okay. That should work for counter. Now label. Label was created in this initialized UI scope. So we'll need another one of these. This one I'll call it closure initialize UI. This gonna heap allocate is gonna have another one, another closure, another dictionary for use as a closure, and then whenever we're accessing the label variable, we need to set heap variable instead. So that is one place where label is set. The other place is here, the pen 2. Okay, and then it's here. Get heap variable and closure initialize UI. Okay, I think that's it probably. And if I run this code, I expect it to work. This feels like it should work. Okay, click, 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 and yeah, it works. And yes, yeah, this code is working. If I look at the current stack, there's nothing in the current stack. Heap. These are texts that show up on the page. I have a counter is 11. That's the closure that contains the counter. Is there a closure that contains the label? It's this one. Yes, I think this is the closure that contains the label. Yeah, and I can. I think a cool way to test this, to see whether it worked, is drop a debugger inside the event handler, and then click the button. So now. Oh wait, there's actually one thing I forgot to do, which is actually want to associate these closures with this frame. So I want, because I'm using both of these closure variables. I mean, not closure, both of these closures. This inner scope, this inner function is making use of variables from both of these closures. I want to tell the debugger by attaching these closures to this frame. Yeah, and this is the use of this closure, and this is the use of that closure. Okay, so I wanted to do that. So let me reload this page to get that change, and now I'm gonna stop in here, click. Okay, so closure initialize UI has the ID of 6, but I'm getting the counter variable from closure main, the main closure, and you would look that up in the heap. So let's see. How are we gonna do this? Gonna open up the console drawer. And did I say it was 6? I think I said it was 6. I'll just try it. So heap at 6. Yeah, that's the closure that has the label variable in it. And if I get the heap variable there, I should get 1. I got 1. Shouldn't I get 10? I don't get it. Oh, closure main is 5. Oh, it is. Oh, it's the closure initialized UI that is 6. Oh, got it. Oh, and that's label. Okay, I'm asking for counter. So the value of counter is 1. And also, because closure main is 5, heap of 5 has the variable counter 1 in it. That makes sense. Let's step through it. And this is gonna set variable, but the normal set variable sets it on the stack. Maybe I should rename this set stack variable. Okay, but this is good. This all looks very good. I'm happy with this. This is what I'm gonna use to implement closures. So now I need to get the generator, the JavaScript code generator to generate JavaScript just like this, instead of me hand editing it. And then if I manage to do that, then I will have closures working in the Play programming language. So let's try that. So what are the things I have to do? Well, number one is we need to use Ast Traversal to figure out which functions need closures, which functions, plus the variable list. Okay, which due to the exercise we did last week with the variable scope coloring, I think we kind of know what we need to do there. Number 2 is we need to add, so for functions whose variables are dependent on by inner scopes, I'll call it inner functions, we need to allocate a dictionary for storing variables I'll say allocate a closure in parentheses a dictionary for with aptly named closure. We need to push all closures. Let me think. Yeah, we need to push ourselves. We need to I wanted to add closures to add the closure closure created above to the push frame function. And then for inner function, for each inner function that depends on an outer closure, we need to, what do we need to do? We need to add the list of closures. Add the list of closures to that we need to the push frame call. Okay, and number 4, for each variable access to a variable in a closure, call the set heap variable or get heap variable functions in place of set variable or get variable. So those are the things we need to do. Yeah, those are the things we need to do. That's a lot. But I think doable. Let's try it. I hope I get to finish this. Okay, so the first one is basically we need to use Ast Traversal, go deep into the tree, and for each function, for each nested function definition or function expression like this, we need to go through all of its variables and figure out whether it's referencing a variable in the outer scope or a variable that it has within its own scope. And if it's referencing something in the outer scope, you need to be specific about which outer scope. Is it this one or is it this one, because the scopes can be nested. Yeah, we are. So let's go ahead and do that. I think maybe the data structure. What data structure would we use? Maybe we create a map that can associate the inner function to a set of like, so maybe for each function we come up with an array of these informations. For example, this inner scope, it has a reference to the initialize UI function, variables within the initial UI function. So it's like, so this is like, we come up with the closures it needs. The function name is initial UI, and then the var variables are these I guess could just be arrays, or it could be a set. In this case it needs label, but it also needs it also needs a variable from the main function. is counter. So maybe we come up with one of these for each function in the program. Okay, let's try that. All right, let's try that. I'm gonna start with I'm gonna save this file. Let's call it closure notes. Okay. And close everything out here. Okay. So the work we did last time, which was color vars, is sort of on the way to doing this for us. But we had to write two very large traverse functions. And I'm in the middle. I was actually in the middle of rewriting them. I actually don't remember the current state of this code. What? Okay, I'm gonna Okay, so this code works. I think that I was in the middle of writing this new traverse function, which I suspect at the moment is unused. So I'm going to delete it and run the program again, and it still works. Okay, so I was correct about that. I'm going to continue doing that work of extracting a reusable traverse function. Okay, if you need to catch up on what I'm doing here, or how I got to this code, you can watch the 3 videos where I created this color vars.js, which basically does this variable coloring here that you see. Okay, so in that process I created 2 very large functions for traversing the AST in subtly different ways, and this code is quite long and complicated, and I want to do a refactoring to this code before I move on and try to implement the closure, what the closure needs. Okay, I'm gonna try to extract a generic traverse function for the AST that can take in a visitor function. So currently we have this traverse, which is really meant to I don't even remember all the things that it did. It did so many things that that I don't even remember. I guess it figured out variable scopes. It assigned IDs to scopes, etc. All these things. It did, and so and then somewhere in the middle of it, there's a place where it needs to do another traversal, but in a slightly different way. But this traversal is just to get the variable assignments, and that is yet another very, very long and complicated recursive function. And a lot of the logic in there is actually duplicated because there's a lot of intelligence in this switch statement that tells it for a given type of AST node what children it has and therefore how to traverse it. I want to extract that smarts into a single reusable function, and then both of these user cases can use that same reusable function. So let's go ahead and do that. The new function I'm gonna want to call it the new function traverse. So I'm gonna rename this existing one to something else. I don't know, or maybe I call the new one traverse AST so I don't have to rename this one. Let's go for that. I'll make a new traverse function. I'll call it traverse AST. And to do that, I'm actually gonna just copy all of this stuff, all of this code, and then paste it, and then strip out the parts we don't want. Sometimes I do it in this way, and other times I like to start over again. Okay, I'm actually gonna read through line by line. Oh, let me rename this to traverse AST, and then if it's a recursive function, you have to remember to rename all of the recursive calls. That's not one though, so I'm not gonna rename that one. Oh, by the way, I'm gonna say that the reason we're doing this, the reason we're refactoring this color coding program before moving on to implementing closures is because the step one of that I laid out, I called it closure nodes. Step one here depends on this refactoring process, because the traverse function that I'm trying to extract right now, the generic traverse function that I'm gonna extract right now, I'm gonna use that to do this AST traversal to figure out that. So that's why we're doing this first, just in case I have not made that clear. Okay, so I renamed all of the recursive calls to traverse AST as well. And this time, okay, this time I'm going to actually root through line by line in this function, and strip out the lines that we don't want. Oh, actually, before doing that, I'm actually going to remove all of these variables except for the node and add a new, parameter, not variable. I'll remove all those parameters here, remove everything except for node, and put in visit. Yeah, because this is going to be a generic traverse function, and the way you would use it, if you saw my video on deleting node modules folders, writing a program to clean up the node modules folders, where I traverse the files within a directory in a recursive way, I did a very, very similar extraction to this. So you could also use that reference for a little bit of background information, but anyway, I'm gonna explain it now as well. I'm gonna use this. This is how I'm planning to use this AST. So I'll get the AST node somewhere, probably by parsing the AST file, and then the user of this traverse AST function will provide this a callback function we'll call this function the visit function because we're using the visitor pattern. And the idea is if you have a tree, an AST tree, let's say this was the AST tree. And different types of nodes have different types of things in them, and that's okay. This traverse AST function is basically saying, okay, let me switch to rainbow color. Okay, if you call traverse AST on this tree, with your visit function, then what I'm gonna do is call this visit function on every node of the tree. So let's number this like 1, 2, 3, 4, 5, 6, 7, 8. So what this traverse AST function promises to do is I'm gonna call visit with node number 1, and I'm gonna call visit with node number 2 and 3 and 4 and all of them. So dot, etc. That's what traverse AST promises to do for you. It makes it easy for you because then you don't have to have this giant switch statement that is knowledgeable about for which kind of AST node, what nested nodes it has contained within it. So that's what we're going for. Let's continue. And you would get the node parameter here, so that would be your node 1, node 2, whatever, and then you can do whatever you want with that node here. Okay. So here, if it's a program node, then we're gonna loop through the program statements. This makes sense, except we're not gonna pass in all of these. We're just gonna pass in the visit function again. Basically all of these traverse AST calls, they should take in just a visit function. It breaks on comment, and that's fine. Comment nodes don't have child nodes, so we're fine with that. Also, let me think about this. At the top is the point where I want to call visit while passing the node. And yeah, let's leave it like that for now. I'm considering allowing this callback function to have a way to say skip. I think we do need that. So if your visit function returns false, then I skip the traversal of its children. I want to allow that. So I'll say I call your visit function. If your visit function returns false, I'll do triple equal false. Then I'm gonna just skip this switch statement, which would traverse further within you. So that's up to the user of this library, whether they want to skip or not. Okay, and then this code here is specific to the coloring program, so I'm not gonna do that. And this if condition is also specific to the coloring program, and I'm also not going to do that. But this recursive traversal I do want for each statement within the code block, so I do want that, but I don't want that or that. And second parameter, I put in the same visit function that we used here. Okay, this is good, and I'm gonna do the same thing here. Put in the visit function here. String literal, there's no need to traverse. String literal has no children. This is specific to the coloring code, so I'm not gonna have that. And I'm gonna put so the variable assignment, you're gonna get a variable assignment node but the right hand side of the variable assignment can be more complex, so we're going to traverse into that. Variable reference, it doesn't have any children, it's just a variable reference. But the dictionary literal has children, so we need to traverse all of its entries and recurse like so. Not sure about this entry key, whether we should traverse the entry key or not. Kind of undecided on that. I'll leave it be here. Okay, for loop. For these calls, I will also just pass in the visit function. Okay, same here. Okay, awesome. I think. Okay, and then if there's a case that we haven't covered, then it'll throw an error to let us know, and if we need to write code for that, then we can do it at that point. I think I'm good with this. Now the idea is we actually want to rewrite both of the original traverse functions using this generic traverse function. So I'm gonna try to do the easier one of the two first, which is to traverse to get variable assignments. How do we traverse to get variable assignments? Let's see. I think what I'm gonna do is I'm gonna make an array to collect all of the variable assignments, and then I'm gonna call the generic traverse ast function with a visitor callback, and then at the end I'll return all the variable assignments. Okay, now the key is the logic in here. This logic, this is all just traversal logic, which already is in here. I am looking for the specific logic that is relevant for this one, and that is if the node is a variable assignment type. So if node type is var assignment, then I want to do this thing, and I guess this results would be this var assignment. Let me call it results, just so that I don't have to change the name. Okay. And this scope ID, find var in scopes. This is gonna get the parent scopes from this parameter. I also get this scope ID here. The results, okay, interesting. I have a feeling I can do this differently this time. Yeah, but I won't do it yet. I'll do it like this for now. Oh, by differently I mean so currently I have this function. The way this function works is you pass in the array of results, I'll push into it, but I think it will be more functional. It will be a more functional style if I created the array of results internally and then return them to you. I'll make one change at a time. So I'll still make this one work like that. Work like the existing way for now. I think all the other code is, yeah, there's nothing special to it. Okay, so I'm gonna remove this code here. Wait, let me just make sure I understand what's going on here. I think I do. I think this looks good to me. Okay, I have the new version of the traverse to get var assignments, which I'm saying this should work the same way as the old one. Let's see if the code still works. No, something actually broke, and I'm not quite sure why. Because previously we had this third level color, and now I don't have that anymore. Interesting. Let me make a copy of this. I'll undo back. Okay, undo back. This is what the code used to be. Okay. And the new version of the code has a problem. Why is that? I'm not sure. I was trying to get a clue by reading through the code about why my new version of the function is not working, but I didn't get a clue, so I'm just gonna try to debug it. Okay, so the problem is this display variable. I'm expecting it to be assigned to a different scope. So traverse to get var assignments. This guy gets called wow, this code was so bad. Okay, it like it created an array and then passes it into a child function which mutates the array, which I really don't like. Okay, let me think. How should I diagnose this? I'm gonna print out here to see. I think it should have encountered this piece of code like about 3 times total. Okay, traverse. I was right about that. I care about the one. Which one am I doing? Closure example 4. This one has 3 statements in it. Okay, let's do the one that has 3 statements in it then. I don't know. But I think the very top thing also has 3 statements. Let me add one more statement in it then. Blah. Okay. Let me compile it. Closure example 4. And now I do it. Now I do this, and then the first one has 4 statements. So now I'm gonna discriminate this one by saying, oh, you have 3 statements. Then I'm gonna print out some debugging information. Okay, now I guess I want to figure out what variable assignments this guy found for me. Let's do this. Child var_defs. I'll pass this guy in, and then after it's done, I'll print them out. Only in this conditional. And then, what? Color is not a function. What line? 53. Oh. We didn't get a color because there was no scope ID, maybe? Let me do this. Defs equals var_defs concat. I think that was a problem when the var_defs didn't have the child var_defs in it. Yep. Okay, so we didn't find any child var_defs when we did this traversal, starting at this code block, which is interesting because I think it should have found that one. So let's try to figure out why that didn't happen. Because I did that. If node.var name that value equals display, I'll just say found display variable. See if it prints that. It did find the display variable, but it didn't get pushed for some reason, and it must be because of this reason. So pushing Okay, I'm gonna print out what this find var in scopes function returned for that scope ID. In one case it was undefined, in another case it was 1. Only if in the case where it's undefined will it push the result. So it should have pushed the result, I suppose. I don't know the fact that there's 2 calls of this. I don't know what to make of that. So I'm gonna print that to see how many times this guy was called. There's several calls to this function. It found the display variable here. Wait, where are all the places this was called? Only one place. But this is a loop, so okay, let me do another printout in the case of length 3 up here. So looking for, that way I can see how many of these traverse to get var assignments calls were for that instance. Okay. Don't have that yet. Okay, so looking for child var refs. Traverse, found it. Oh, there's a previous traversal that found the display variable. And assigned a scope to it, maybe? As in this traversal, it find the display variable, but it shouldn't have. So okay, I think I understand why. So when I was looking for variable assignments in the previous scope, probably, let's say here, I'm not sure if it's this, or it could even be this one. It drilled down too deep and it found that, so we don't want that. And to prevent that, we want it to, when it's searching for variable assignments for this scope, we don't want it to drill deeper than that. So if we see a function expression or a function definition, we should return false from the visit function to tell it to not go any further. So that's what we need to do, I think. Let's try that. Where do we need to do that? Here. Okay, great. Okay, so else if node type is a function expression or node type is a function definition, I want to return false because that's important. Okay, that fixed it. Perfect. Alright, let me get rid of the console.log statements. in various places that I'm using for debugging, and which is kind of a pain. Partly why I am working on the time traveling feature, because if we had time traveling, then we wouldn't have to use console.log statements anymore. Alright, let's see if this works. That does work. That looks great. Okay, so we were successful in rewriting the traverse to get var assignments function using this generic traverse ast. You notice that now this function is so much smaller than before, and we can actually read this code fairly quickly. There's a lot of complexity dealing with ast traversal that is been moved out to this generic function now. So when you're traversing an ast, you don't have to worry about that anymore, and that's nice. And this ability to skip traversal for certain nodes, we need that sometimes, as in this case, and that's nice as well. Okay, so now oh yeah, one more thing I wanted to do was I actually think it would be it'd be better to not pass in the results and then append to it, but rather construct the results here and then return them. And if we did that, the caller would have to collect them like this, but we can just sort of do this to push these results onto this variable. Let's not bother with the child or refs variable then, if we're gonna do it this way. It makes the handshake a little simpler, I think, and I don't like mutation, so we avoided mutation. This should still work, and it does. Great. Okay, now we have a generic traverse function. Let's also rewrite this traverse function to use the generic traverse function. There's a reason why this function is nested inside of the other function. I'm not gonna try to tamper with that. I don't think this function though needs to be inside. I'm gonna move it out, see if it still works. It does, so I can move it outside. But the function that's on the inside, it's probably inside for a reason. Maybe it needs to call this assign ID function, is my guess. Okay, so this big old function, I want to rewrite it. Okay, I write version 2 of it by calling the traverse ast, the generic version of the function, and sort of moving the logic into this visitor function here. So let me see. So there's a lot of logic here that we are going to need. I think for the case of the code block. So I'll say if node type is code block, then all of that. Also, I had another idea about how to simplify that code, but I'll do it after this refactoring here. In the case of variable assignments, then we need this. I might need, no, okay. Alright, I'm gonna do it like this. So if it's a variable assignment, instead of a code block, then this stuff, this guy also tries to push the results into an array, and I think I would like to change that as well. And I think this is kind of easy to do, actually. I might even do it right away this time. Like that, and then at the end. And I would even rename this to not be traverse because there's a better name for it. But I'll do that later. Okay. So this is for the case where they know there's a var assignment. We want to do this. What are other specialized logic? When it's a var reference, then we want to do this. All the other stuff I think is just traversal logic. I think. Okay. Oh, there's one case here with the for loop where I need to pass down the loop variable as an extra parameter. Oh, and also this case with the function expression. Okay, that is important. One second, someone's at the door. Okay, my kids are home. So excuse the noise a little bit. I'm gonna try to keep working on this a little bit as long as I can. Okay, so this logic I think belongs in here, and then, but we also have to specialize for the for loop case and the function expression case. Okay, so else and function definition case too. Okay, so this case actually is a special case where I guess I want to customize the traversal by calling back to this traverse instead of this traverse. So what would I call this traverse at this point? Find variable reference scopes. Let's call this reference scopes. This is a case where we actually want to perform the traversal in a specialized way. Because we don't want to do this pass down thing. There's another way of handling this without this complication, but I'm gonna do it this way first. So this is actually still recursing back to itself. So in this specialized case, we're returning false to tell this traverse AST not to recurse. We'll basically do it ourselves, which when this subcall does its thing, it will actually still call traverse AST to do yet another traversal, but at that point, and because we changed the parameter, the signature of the function to not have a results parameter, we'll do it like this, but we'll push it onto this results here. I apologize if this code is getting slightly hard to follow. But I think this can work out without too much trouble if we are lucky. Well, let's see. We'll do the same here. We'll turn off the automatic traversal, but do the customized traversal like this, and then push its results into this results in the parent level. I'm wondering whether there's logic here that, yeah, there's stuff here. This calls the other function though. Oh, but this one calls traverse. So this is actually, should we use this custom traversal or not? Yeah, I think I should use the custom traversal for this case. Yeah. But if I'm using custom traversal, that means I want to rename the called function. Like that. And here I want to return false. And child results. Like that. Okay. Wow. I changed a ton of code. I hope this works now. Actually, since I renamed the new function that I'm working on, I'm just gonna change the function that's called, and that doesn't work. Let's fix it. 143 return result. Return results is probably what I meant. That did not work at all. So, okay. That's because you no longer pass to it the results. Instead, you receive the results from it. Oh, yes, it still works. Amazing. I honestly didn't expect that to work so easily. So this large function is no longer, we've replaced it with a simpler looking function at this point, although still kind of complex. This function is still kind of complex. I'm gonna try to, well, I'm actually not sure whether I wanna refactor this function to clean it up, or just go right to working on the closures. Let me think about that. I'm gonna try to move this function out, and I think if I try to do that, then it won't work because it needs this assign ID function in order to work. This code is still a little bit complex, maybe a lot complex, but I follow its logic. I did it last week and I can still remember why I did this. Okay, but in any case, we have this traverse AST function that works in a very generic way, and that is great. And maybe I leave it at that. Yeah, I'm actually gonna leave it at that. And now that I have a reusable traverse AST function, I'm gonna move that out and use it for my next assignment. Interestingly, I had previously made another traverser called traverse and collect, which is not quite as generic as this one, but this one is more generic, so I actually like this one better than that one. Okay, so I have my traverse function now in my traverser sort of module, and now I can make code. I can make another piece of code that would use this to find the closure information. So let me do this. I'm gonna make a script, a new script. I'm going to call it closure info .js. Its job is to get the closure info, and it's for every function in the program, it will provide the closure info for that function. The info being whether it needs to sort of save some of its variables in a closure instead of saving them in the normal stack, and also whether for a given function whether for what variables within it should come from the stack versus a closure, and if it's a closure, which closure, because a certain inner function may make use of multiple closures. So that's what this code is gonna do now. All right, let's just do it. I'm gonna need this traverse function that we just made. Okay. I'm gonna use the file system module, and I learned recently that we actually don't even need the MZ module anymore to do file system some things in the async await style, because the file system has a promises sort of submodule inside the module, which has all the methods in promise-ified version, such as reader, etc. So I'm just gonna use this instead of MZ. And okay, let me make an async main function and call this main function. And if there's a problem, I'll print out a stack trace. Okay, and then let's say closure info. Let's just have closure info taken an AST file. So file name will come from process.argv2. If you forgot to give me a file name, I'm gonna print out, please provide a file name and exit. Otherwise, for now, I'll print out the file name to make sure I got this right so far. Okay, what I would have expected it to print this, but it didn't. Oh, if not file name, then please provide a file name. I'm going to provide a file name and say closure example 4.ast. That's the AST file is what I'm expecting. So given that, let's use the file system promises submodule to read the file given by the file name, and once we read it, I need to await it first, and then we'll get a buffer object, and then we do a toString to get the string, and now we're gonna JSON.parse. Now get the AST. Let me just print out, make sure I got the AST. No. File name. There's the AST. Good. Okay, now we're gonna traverse. I'll just make a get closure info function, pass in the AST, and expect the closure info to be there, and then I'll print out the closure info. Okay, now I make that function. Okay, and this one is the one that's gonna use this new traverse function. Oh, it's actually called traverse AST, isn't it? I think I actually would like to call it just traverse. So I'm gonna replace references to traverse AST, replace it with just traverse. Okay. Alright, just called traverse now. Alright, so how are we gonna do this? Let me look at the color vars JS as a reference. Okay, so basically we want to find all the either variable assignments, or there's multiple things you're trying to do. For when you encounter a function, either a function definition or a function expression, that's when you need to start doing stuff. First of all, that's when you need to get the closure info for it. So perhaps what we do is traverse AST and say if the node is either a function definition or a function expression, we need to get closure information for it. but a sub procedure there. Excuse the motorcycle outside. So I'm thinking I want another function. I'm just gonna call this maybe gather closure info. It's a weird name, I know, but here I wanna get closure info. Gather closure info is like I'm gonna gather all the closure info for all of the functions, whereas get closure info is like for this function. I'm not sure if that's the way I want to do it. I feel like it's doing two things at the same time. One of the things it's doing is collecting variable references and variable assignments. Wait, maybe it doesn't have to do that anymore. Is that true? This one gets all variable assignments. Oh, I see. Oh, it kind of does need to do this for the variable coloring case. It's looking for all the variable references. I think during the traversal, you need a context of what scope you're in at the given moment for when you are looking for a variable assignment. Let me try this. Let's do baby steps first. And I don't want to morph the variable coloring one into this one because I think that can muddle things. I'm just gonna try to find. I'm gonna stop recursing at the first function definition, which would be the main function in this case, and it's just gonna find all of the variable references within it. Find variable references and assignments. Or do we want to do them separately? Okay, let's But I'm gonna make a separate function and then to find their variable references. Which is also going to have this recursive traversal thing. I'll call this fun node. So if I find a variable reference, I am basically going to collect it. Like that. But if we're not gonna drill down into nested function definitions or function expressions. Oh, and for the one we did with the color scopes, we also differentiated block scoping, like the blocks within if statements and the blocks within loops. We're not going to do that for this one to simplify how closures work. Okay. So we're just going to find the variable references within the scope of this function node. But if we see a nested function definition or function expression, we're not going to traverse down. We're gonna skip. Yeah. Alright, let's see how that works. We found nothing. Closure example 4. Is that the one we're working with? I should have found this. Oh. Okay. But that's a variable assignment. Okay. That's fine. I'll make a separate one for variable assignments. Okay, that should get us to variable assignments. No, it didn't. Why is that? What's going on? Var assignment counter. Yeah, there's a var assignment here. Why didn't I find this var assignment? I don't get it. Verifying the variable assignments. Let me print out this function. Note. Okay, this is the main function. That makes sense. Not sure what's going on. There's a lot of noise right now. I think I'm gonna wait until. Okay, alright. Let's try to debug this problem. Let me think. We're not getting any variable assignments either. We never hit this. Oops. Var assignment. I'll just print out all the node types that we encountered here. Function definition is the only node type we encountered. And it sort of got skipped. If we didn't skip, well, oh, this is for variable references. I was looking at the wrong one. Okay, try again. Alright, if we didn't skip the functions, then we'll get a lot of variable assignments. Oh, I have a feeling. I maybe I know. Go into the traverse function. Visit the node. When we get a code block. idea. I can simplify this program. Okay, so this. Alright, I couldn't find this variable assignment, even in this case, so that is very strange, and I think it's easier to look into that now. Find variable assignments. It didn't even go into anything. Oh, I know, because we already skipped. The first node is the function node, and we already skipped it, so there's no traversal whatsoever. What we could do is traverse its body to find things. Yes, that's what we should have done. And now you would find things. Okay. That took me a while. That really stumped me. Okay, let's go back to what the code was. Compile it. And now try. And now we get two variable assignments to name and counter. Which is correct. So those are these two. Okay, so now we're armed with both the variable references and the variable assignments within the body of either a function definition or a function expression, but without going into the nested functions. Let's also have one to get nested functions. Inner functions. I like this way of doing it. There's a lot of customized traversals, all using this generic traverse function. This is actually a block node, not a fun node. So I'm gonna rename it. Okay, I'll do the same deal like this. To print this thing out. Okay, so if it's one of these, if it's a function definition or a function expression, then put it into the results and skip further traversal. That's it. So let's see if it were able to find the inner functions for us. Oops. Inner functions. So we have the initialize UI function. And yeah, that's all of the inner functions. Okay, great. All right, let me think about how to deal with this at this point. So I have at this point I'm dealing with a main function. I need to gather my closure info, but in order to gather my closure info, I need to consult my inner functions first. And I'm gonna tell my inner functions what are my variables, what are the variables declared within me, and those are these plus my parameter list. So node parameters, I'm gonna also print them out. I think for the purpose of better, so that I can read, and also you, whoever's watching me, can read this better, I'm gonna do it like this. So function, maybe like this, function node dot fun name. I think I called it fun name. Maybe. Function definition has, it's just name. Okay, so just name that value. That's the function's name. Parameters, I can map it over param dot value, I think. And I think same with the variable references. Let me try this first. Okay, so I have function, but the function has no parameters. Variable, I wanna indent these. And do we have variable assignments? We do. So, but the variable assignments have like I'm a little tired, so I might bring this to a close soon. But I'll finish this a little bit. Okay, I think this is nice. Maybe like this. So, okay, so given the function main, it's got these parameters, these variable references, these variable assignments, and therefore from this we know that main function has defined these two. So say variable definitions var defs is the combination of the parameters with the variable assignments that were found. Yeah. So perhaps I'm gonna print out the var defs. I think I need to map it to just the var name for the variable definitions or variable assignments. Okay, that worked. These are the variable definitions and name and counter for this scope. We didn't have any variable references, and that's fine. But if we had, that would tell you whether the reference refers to something in this scope or a scope outside, and we can use that information to determine whether it's using a closure or not. Okay. Alright, I think this video has gone on long enough. I'm gonna stop it and regroup and perhaps finish off this task at a different date.